So good afternoon, everyone. Today I'm here to talk about how you could react or just get you started on the reactive programming. And this theater really is big. I'm basically a what, why, and how person. So that is exactly what I'll be talking now. I'll be sharing my views about why most of the things are magically becoming reactive nowadays, and why the deployment model structured around asynchronous data streams are talk of the town. So, yeah. I am Jayashree S Kumar. I am a IBM Java's classes library developer. I'm part of runtimes team from IBM Software Labs. When I'm not at work, this keeps me busy, and this is my second time coming to EclipseCon and using this picture as well. So, all right then, I'll just get started with a very brief on paradigms. Programming paradigms are nothing but the style of how you program, the way of thinking or how you would approach a problem. We have two main types, the imperative, which deals about how you'll go about solving your problem. It defines the control flow, whereas we have our declarative type, which deals about what exactly will you solve. Your business logic is what your program logic is what you define, and not the control flow. Our reactive programming today is part of a data flow type declarative programming style. It basically just concerns itself with data streams, that is the sequence of events, and how the propagation of change happens. Yeah, a small example is like here, A is equal to 10, B is equal to A plus 1. In our imperative style of program, B will be equivalent to A plus 1 in that instance when it is getting evaluated. And later when A is equal to 11, it has no impact on B whatsoever. B will still remain to be equivalent to 11. However, in reactive, once you have said B is equal to A plus 1, every time A's value keeps getting changed, it will immediately be shown for B as well. Okay. Stream itself is a metaphor, but for simpler understanding, I thought I'll just quote some examples here. Let's consider the water flowing through the pipe is your data. So the pipe itself becomes your stream. Here, it allows you for sequential access of data. The water keeps coming. You need not know from where the water is coming, whether it's from river, tap, lake, or anywhere. Your user just needs to be concerned about getting the data. It could come from, say, socket, file, object, or anywhere. All the user needs to do is try to manipulate his data according to his execution, and that's it. So stream provides a kind of abstraction for you to make use of your data and execute them accordingly. Conveyor belt is one more example where the belt itself is the stream while the bags are your datas. Picking the bag up would be your input stream, where you're taking off the data, while putting the bag down would be your output stream. You're writing onto the stream. So in programming terms, streams are wrappers around your data sources, which allows you to operate on the data store, like I said, and making the bulk processing convenient and faster. A stream does not or is not a data structure because it does not stores any data. All it does is, it never touches or modifies the underlying data. Yeah. While we are talking about stream, there are two types of transfers of data, the synchronous type and the asynchronous type. In synchronous, your sender and receiver needs to be synced, and only data is sent sequentially, one after the other. Only after acknowledgement is received, another data is sent. While in asynchronous, the sender and receiver need not be in sync, and the data sending can just happen as you want. I've taken the example of a call and a message here. In a call, I say, hello, John, you say, hello, Jay. I say, how are you? And then say, you're fine. So it happens one after the other. Whereas in my messaging, I would simply start shooting the messages as, hello, John, how are you? Where are you? And everything. And you could take and process the data and reply to me whenever you wish. Synchronous is faster and expensive, and asynchronous is slower and, let's say, expensive. Let me move on to the what, whys, and whens of reactive programming. So, reactive programming is not something new. It has been there for a very long time. If you see, since 1960s, you could read the word. So why are we talking about reactive now? And yeah, so there are certain points that I have put here, which are main reasons for pushing to reactivity. One being, in the recent years, the hardware improvements of your systems are too huge. With you going on virtualization, container, and cloud-based deployment infrastructure, the software also, it becomes for the software also to catch up to be able to utilize this hardware. The application requirements have also changed dramatically. If you see, just a few years ago, we had a very large application which was running on tens of servers. It could have a response time in seconds and a downtime of, say, hours together. We dealt with gigabytes of data. But now, with today's application, which is deployed everywhere, which is running on thousands of multi-core processors, we expect millisecond of response and 100% uptime always, and we deal with petabyte of data. This is where the changing application trends and yeah. Earlier, I just used to have hardly a device, one laptop, but now I have my IoT watches, my laptop, my phone, and I'm being online always, and I need to be in sync at all the time. So these, like I said, are pushing us towards becoming faster and more responsive. We expect our systems to be more responsive. We just want the accuracy to be there as well. It shouldn't suffer that as well. So that is why lots and lots of tools and libraries that are coming up now, the approaches that people are taking are in the reactive way. Like any new concept or like any old concept that we keep discussing again, for reactive also, around 2013, Reactive Manifesto was made, which was led by a Lightbend, and it was simply a declaration of ideals of how modern software design should be today. So they just wanted to make a standard. So they said they introduced, Reactive Manifesto actually introduced the reactive systems. It had 4 sacred principles where it promised to be more flexible, loosely coupled, and highly responsive systems which are more failure tolerant. More information, I mean, you could find all the information in manifesto. The 4 reactive principles. So far I have been using reactive, the reactive manifesto, reactive systems, now the reactive principle. I'll draw parallels with everything in the in later slide. So yeah, the 4 core pillars are responsiveness. Your system should respond always. It shouldn't be that a programmer is talking to it, and if some failure happens, it doesn't respond back. That is not the case. In this, they say your system should be responsive at all the times. It should be elastic. Whenever a sale comes, your Amazon should be able to cater to all the tens and thousands of users that are using, and when there is no sale, it should just go back to relieving the resources that it has. Literally like an elastic band, the system should be able to increase and compress. It should be more resilient. This is one of the important principle of reactive systems, where it deals with the it treats the failures as first-class citizens. Unlike in Java, if you hit a failure, they are simply caught in their exception is thrown. But here in these systems, in reactor systems, you have to deal with it. If a failure happens, what next will happen? That is how the reactor systems are built. And message-driven is simply nothing but the idea that each one of the independently running components can talk to each other with the messages. So I'm moving on. With next, Reactive Manifesto, Principle System, now Reactive Streams. So this is yet another organization came together in the same year 2013. They called themselves Reactive Stream. It was led by Netflix, Pivotal and Lightbelt. Later Oracle as well joined it, Oracle, Twitter and Red Hat. So they took the Reactive Manifesto and created a specification which dictated how to achieve some of the principles. It basically is just a blueprint for implementing reactive programming. It then became a JVM standard for asynchronous stream processing with non-blocking backpressure. So asynchronous stream processing, why? Because I kept discussing why we need asynchronous. It is like sending messages in a highly concurrent way so that you can make use of the multi-core hardware. Any core within your CPU can start processing the message events that you sent. And it should be non-blocking. It would mean the ability to make continuous progress in order for your application to be responsive. Like I said, you need your system to be responsive, and you do not want any thread waiting for something. You want your thread to always keep working. So that is where non-blocking comes. And for backpressure, to explain the backpressure, I will take you guys through this slide. I have borrowed this from internet. So yeah, in the generalized stream processing, what happens is you have your source of data, the producer. He produces the data and sends it to the destination of data, the consumer. While it is going from producer to consumer, there are various processing stages. And so in this case, consider if producer and consumer are on different speeds, then if the downstream, that is the consumer, is faster than upstream producer, it wouldn't matter, you're all good. But if the downstream is slower than the upstream, the producer, then what could happen? It'll start getting worse. Your data processing will not happen. You could do three things. One is, if the consumer is slow, you could buffer the data, but you cannot keep buffering. There is a limit. Another is you can drop the data, which not in all cases is good. And the last one is you could block until the consumer is ready, but that will actually slow down the complete pipeline, your complete pipeline. So this way of dealing with different capabilities in techniques is backpressure. Here, the backpressure actually sends a request to the producer saying consumer can only process n request, so you please just send n request. Do not send more than that. In this way, we are making sure we are making sure there is a continuous processing of your data. Yeah, so reactive streams, the three key factors which makes your stream reactive is that the data are processed asynchronously and the backpressure is non-blocking. Then the downstream's slowness is somehow known to the upstream. In all the systems that streams you build, you make sure the producer is always aware that the consumer cannot take it. Reactive Stream has a specification, and this specification consists of API specs where you have your Java API, and textually it is this Java API implements your reactive streams, and it helps you achieve interoperability between different implementations. That's why they came up with this standard. Then there is this TCK. Any implementation that you do write for reactive stream needs to pass this TCK in order to be interoperable. I am now coming to reactive programming. Reactive programming is programming with asynchronous data stream. So, yeah. So, asynchronous data streams are sequence of ongoing events that are happening over time. It can emit three different types of things. One is like any type of value, A, B, C, D, or an error, or a complete signal. So, we capture the, let's consider this click a button event. While this event is happening, we capture the emitted events A, B, C, D asynchronously by defining a function that will execute when the value is emitted. So another function is written for error and one is written for complete as well. So every time these kind of different values come out, the function makes sure it is caught and it works. So the listening to the stream is called subscribing. And the functions we define are the observers. They keep observing, and when they see A, the function will work. When they see error, it will work. And the stream is the subject. I mean, stream is the subject or the observables. So these three things, subscribing, observers, and the observables. These are the key terminologies that many reactive tool implementation make use of. So that is why I spent some time here. Benefits of reactive programming to user. I had one more slide which shows reactive programming benefits for as programmers, but I'll not deal with that. We see increased performance because we handle a huge amount of volume of data quickly and in a stable way, so the performance is good. But speed is not. How that is not, I'll show later. And yeah, increased resource utilization. Your thread never sits and waits. All the resources that are available to you are used at all the times. And because your system is being used and it is responsive, the user gets a better experience and they feel more happy. Where and when to use reactive programming? Very simple. Wherever there is huge load of data and multi-user applications come into picture, like your social networks, your chat, gaming places, artificial intelligence and machine learning are also using reactive, and any real-time data streaming is where you would use your reactive programming. And where you will not use is again simple. Wherever there is no live data, there is no huge load of data, and there are not many users trying to change the data simultaneously. You do not need reactive programming there. Yeah, so this was the figure that I was saying, all reactives. So we started with the Reactive Manifesto, which came up, which was made for reactive systems, and reactive systems were built of 4 principles, reactive principles. And then another organization, Reactive Streams, came up to enable or to incorporate the Reactive Manifesto principles and try writing the reactive programming. It's for that. And reactive programming, yeah, there is a standard for that. That is the Reactive Stream specifications. So this is how all the reactive just sits into the picture. I didn't talk about one more reactive, that is the reactive extension. Reactive extension is a set of tools allowing any imperative programming language to operate on sequence of data. I mean, imperative to become like a declarative type like a reactive. So that is reactive extension, and we'll be seeing about it as well in some time. Yeah, so we spoke about reactive. Now, why reactive in Java? Since Java came in 1995, it was not just the language, but the complete platform was a immediate hit with its auto management. People started writing real production code, and with garbage collection, lots of people liked it, and like millions of people liked it. It's been around for 24 years now, and people still love it. Under the stewardship of Sun and Oracle, it has actually amazed a huge and active developer community of 8 million people. So yeah, so it has been quite a predominant language for almost a long time. So all the major industries have major investments in Java. Not just that, Java's impact on modern world is very far-reaching, not just to the computing people, but in the day-to-day life of non-programming folks as well. If you take our mobile, Android, our software products, Gmail, OpenOffice, Eclipse, then games, hospitals and military, everywhere. Java is already having a huge market out there. But to solve today's business problems on modern topologies, using modern release practices and with increasingly modularized application architecture, it is becoming very difficult. And precisely because Java is strongly object-oriented, high performance and multi-platform capability, it is they had to get better in dealing with asynchronous data. That is why, of course, Java had to modernize in multiple ways. The Java developers have always been on watch, and they just wanted to make this awesome language more awesome. And they started the modernization journey from Java 8 onwards, which was the most feature-packed release. They introduced functional programming, which is, again, a very good paradigm, you will know. And in Java 9 onwards, it was a new release train that happened, and module system project Jigsaw was a big thing. Apart from project Jigsaw, there was 85 non-module JEPs, in which HTTP2 client and JShell and lots of improvement to concurrency came in. And that is where Reactive Streams was introduced into Java 9, into the concurrency library class. So flow, I said Java 9 onwards, Reactive Streams were introduced into JDK. I would say why? When Reactive Streams started their initiative, it was basically to standardize the exchange of asynchronous data between software components. So as more frameworks and libraries builder supported this initiative, various Java implementation started appearing, and because of its simplicity, the simplicity of Reactive Stream standards, many interfaces were made up with these implementation. The implementation were mostly identical but with different terms, and it was confusing the Java application developer to think which should they go with or what should they do. It was like I said, highly confusing. That is where the Reactive Stream decided that in order to reduce this duplication and the imputation incompatibility, they included the basic interfaces for each of the fundamental Reactive Stream concepts in this flow concurrency library. It came under Java util concurrency.flow class. So it didn't bring anything new or special. It just tried to bring together this set of rules and simplify the standard of reactivity. We have 4 basic interfaces in Java 9 flow class, which is like publisher, subscriber, subscription, and processor. What each of them does is, the publisher is a producer of items, while the subscriber, it is start of the pipe. It produces and it gives the items to the subscriber. The subscriber receives the message, while the subscription is, it is a message control linking flow publisher and the subscriber. And the processor, it acts as both publisher and subscription. Java also has one more standalone submission publisher class, which has its own uses. I'm just trying to represent all that here. We have our publisher, which has a subscribe method using which it will connect to it. Subscribe method using which a subscriber will connect to the publisher. And then in subscriber interface, we have receive receives a confirmation via on subscribe. It receives the confirmation that the connection is set, and then on next it will be reading the items that the publisher is sending. On complete and on error are, like I showed, it could emit 3 different values, asynchronous data streams, so it will throw that function there. Okay, goals of Reactor Stream and JDK is just that it's to provide a service provider interface, not the actual API, it's just a service provider interface. Okay, I'm running out of time. So I just had this small program that I wrote for the flow class, where we are creating a basic subscriber which actually asks for, in the subscription, this is a subscriber, and on request it is asking the producer to give me one data after other. It will read, it will print, and it will ask again. So I wrote the publishers submit. I used the submission publisher class which Java already gives. That is why I got my submit here. So it takes the submit item function and it invokes the on next. And I have my output here. So I'll just go. It is after Reactive Stream came into Java, it is always good, the talk around the internet, and even I would suggest that you do not go to write your own implementation. You just make use of this Reactive Stream and try to try to use the already existing tools that are implemented and verified by TCK. If I had written this implementation, now for me to go ahead, I will need to run TCK on this. I might hit a lot of bugs. There are tools which will help us do this. So it is better to use the existing ones. The existing tools or help for you are for Java Reactor programming, it is RxJava, which was the first fully fledged reactive extension API. It is specific to Java platform, and it worked with Java 6 onwards. This was pre-reactive stream specification time itself. It provided an opportunity to write asynchronous event-based programs for Java and the Android users. So RxJava 2 is what is conforming to the reactive streams now, which is released. It has a flowable implement which works with Backpressure. And there is Spring Reactor, which is another framework for Java by the Spring developers. It is similar to RxJava. The main lead in both are same. Yeah. And for reactive streams, for reactive systems in Java, there is like Akka and Eclipse Vertex. So both of them are, these are frameworks that are used to build the microservices systems, microservices reactive systems. So yeah, you guys could just go on. And I'll just quickly go to the conclusion. I just have 1 more minute. So last example, just so that you'll not, Mary finishes work. She orders a pizza. She waits till it is done, picks up her friend, and finally, pizza and friend together, they go home and sit and eat pizza and watch movie. That is the synchronous approach. While the asynchronous is, Mary orders pizza, she calls friend and asks her to come. She simply heads home and her pizza gets delivered. She starts eating pizza without her friend. That is the async approach. While the reactive approach would be waiting for all the asynchronous actions, where your pizza is ordered, you call your friend, you are headed home, your pizza is delivered, you wait for your friend to come, and then only you watch a movie and eat pizza. That is the reactive approach. Yeah. I do know to each his own, so but I wanted to just show that give reactive programming a chance. It is not that you have to start completely overturning your application into reactive programming, but you could start appreciating the beauty of reactive programming into your program in small bite-sized, and you surely will see the difference. So that is why I do give reactive programming a chance. And yeah, it is not for faint of heart, and it is a way of thinking. It's not just like functional programming, you would just pull in a API into your program and start using. This is not like that. You need to think even before you have started your program. it needs to happen that way. And yeah, all the recap is done. Please do evaluate this session, and thank you for attending it. That's all. There is 5 more minutes for any questions.